What's new with JUnit? But wait, before we address that question, let me ask you, why do you care? I guess the answer is simple. If you are a Java developer, you use JUnit often to test your code. I mean, we all test our code. We do, right? And this makes today's session interesting because we have with us the amazing JUnit crew, and they'll talk about, guess what? The question we all love, and that is, what's new? They'll not only talk about the new features in the recent 5.11 release of JUnit, but also highlights from 5.9 and 5.10. And you'll also get a sneak peek on what's coming in JUnit 5.12. So, what are we waiting for? Hi, everyone. Thanks for joining in for another episode of IntelliJ Idea Livestream. I'm your host, Mala Gupta. You have no idea how excited I am for today's session. And on that note, let me add our speakers Christian, Mark, Sam, and Juliet. Hey, everyone. A pleasure to have you all with us today.
Hi, Mala.
Hi. It's a
Hi.
pleasure to be here.
Mark, I would request you to get started and introduce yourself.
Sure. Hey, I'm Mark. I'm the team lead of the JUnit team, and we also have Christian with us today, and Juliette, and Sam. So it's like the entire team.
So, Mark, how does it feel to have your team meeting, which is live and being seen by everyone across the globe? Not everyone,
so far so good. Thanks. Yeah. So far so good. We actually had a real team meeting last week in person, and we met in Switzerland, and tackled some issues, and it was great fun.
Sounds good. I'm really excited for today's session because, of course, I know all of you are great people, not just great leaders and experts. So I'm really looking forward to today's session. But before I let every one of you take the stage, I have some quick housekeeping details for everyone who is watching today's session. Please use the YouTube chat to post your question. We'll try to answer your question as you post them. I and Bas from the JetBrains team will answer your questions. Yes, the most important question, this session is being recorded and will be hosted on IntelliJ Ideas YouTube channel. So if you haven't already subscribed to our channel, now is the time to do that. And if you like today's session, which I am very sure you will, do not miss to like the video. And on that note, Mark, let me add your screen to the stream. And the remaining of us will be backstage and have fun.
Thanks. All right. Yeah, so welcome again to the JUnit crew presents what's new. And this is us, if you've only seen us. This is actually a picture from the team meeting last week that I mentioned. So we had, the Duke also with us, our kind of mascot, since we won the Duke's Choice Award a couple of years ago. That kind of gets passed around at team meetings. Yeah, I would like to start with some good news that we had recently. This is a chart that shows the Maven Central downloads of JUnit Jupiter per month. And as of September, we reached 50 million downloads per month, which is a pretty good number, I think. And what makes it even better is that it's exceeding the download numbers of JUnit 4 and 3, which are at 45 and 27 million downloads per month, respectively. So that was really exciting news for us. Can we finally start passing the old JUnit versions? And also, you can see the download numbers of the JUnit 5 BOM, which is like the bill of materials that aligns all dependency versions at 129 million downloads per month, so even higher, which is a clear indicator that the whole platform idea that kind of is behind JUnit 5 has really taken off. Moreover, new projects that use Spring Initializer or Gradle's init task now use JUnit Jupiter by default, which is also great news that new projects start with the modern testing framework right away. And we are used by 477,000 repositories in GitHub. I haven't looked at them all, obviously, but it's quite a high number. And I always find this mind-blowing, to be honest. So yeah, and basically to summarize, JUnit Jupiter is now the most used testing framework for Java, and we are really excited about that. At this stage, I would like to thank our sponsors. I'm not sure you're aware, but you can sponsor JUnit and its development. We use that, for example, for such team meetings. So if your company is getting a lot of value out of JUnit, we're also always happy to welcome more sponsors, and you could go to the JUnit website to learn more. And with that, I'm going to hand it over to Christian, who is going to present enhancement to the platform and console launcher.
Right. Okay. I'm Christian, working for the JUnit team and also for Oracle and the Java LangTools team, and trying to get testing all over the place done. And one thing that Mark already mentioned was that we have with JUnit 5 the platform as the foundation of the entire spiel. And on that platform, there are the test engines like Jupiter. You might have already heard about that before. What I want to take now is look at the basics at the platform and the first client or tool that is connecting to that is the console. And here we have some improvements on the console, on the command line, which is our own launcher we ship with JUnit, and it now provides a version option, and we're going to see that live 1 minute later. As the functionality of the launcher has been growing more and more, we decided to introduce subcommands, and now we have an execute subcommand for executing tests and notifying engines that they should look for tests and run them. And the first step, looking for tests, we call it discovery, or the discover subcommand handles that. So when you want to know which tests are in your entire selection of tests, you can go to the command line and have a discover subcommand run and see which static tests are part of your project or multi-module project even. And in between those two, there is a new dry run mode, which actually discovers and executes tests almost, which then just don't call the test method. It's just a dry run, but all the listeners and the registered listeners can do the work, and so you can verify that everything is working as intended. So let me switch over my screen to the demo repository, which is on GitHub already, JUnit 5 demos November 2024. And here I started a session on code spaces, which should be up and running. You see the URL again. And for me, now presenting core foundation usage of the console launcher, I rely on Gradle to build the classes and the test classes, because JUnit doesn't come with a build feature. But without further ado, let's get the latest snapshot, 1.12 actually, so we are a bit in the future right now. Because while rehearsing the slides or the non-slide version of this, we found a bug and we fixed it already for you, but later more to that. So let me copy that over, get the jar file from Maven Central, which is now called JUnit jar. It's down here in the bottom left in my directory, and we can just call any Java launcher with the jar command and have the JUnit jar part of it and see the help screen. Let me make this a bit bigger for you. And here you see we have the launcher with this new subcommands and the help screen which is showing. And the first thing I want to show is the version flag, which now reads 1.12 snapshot, could read 1.11.3 for you, and shows which Java version we are on and which machine is running on. So with that, we can see interesting information already. And the other thing, interesting information, is the engines subcommand, which was listed here, which lists all available engines at runtime. So if I remove the option here and say engines, we See this now on top. We have 3 engines included, which is JUnit Jupiter, which is JUnit Vintage, which reaches out to JUnit 3 and 4 jars, and also included is a platform suite engine, which Julian will talk later a bit about. If you have custom engines, which are part of the class path or module path, they would show up here. So if you're missing something, use this subcommand to find all the engines that are live and kicking. Now, as I said, let's compile the current project with Gradle to get the Java sources built into classes and use the right key. Here we go. Everything is built already. That's good. And now let's discover tests, which are part of the project. They all went down into the build directory. There's the classes. Here we have the test sources. So something is here. And in order to not mistype like I did before, I copied over most of the commands into a simple text file, which contains the options I would type on the command shell and call the ConsoleLauncher here as the last argument, which is nothing different than the JUnit-jar option just did it with the executable jar file before. But now I can just recall all those or replay all those options from this file by using a arguments file, just that I don't talk sheep. Let's see if it still works. It does. And if I use another subcommand like the discover subcommand, we're going to see a lot of tests. This is a breakpoint that was expected. So if something is a mess with your command line, you get a very long and detailed information what is possible with the launcher. And in this time, he said, please specify an explicit selector option or use class scan class path or scan modules to see which tests are part of the class path. So let's add this scan class path. And lo and behold, we're going to see which tests are part of this project. And we see there is a JUnit platform node here. There's a Jupyter node and a Vintage node on the top level. And there are containers and tests in a more blue color. If you're doing this on a CI server, you can set the no color option, and then this will no longer be shown. And this we're going to see in the end. And after discovering the tests, we can also execute them. Just replace the discover subcommand with the execute command. And here we go. The summary is now longer. It's not only found, but also started, and most of them were successful. All of them. Depends on the state of your project, of course. If something is red, you're going to see that as well. So one thing I wanted to show as my last demo here for the console launcher is that you can enable extensions globally. And this is done in the classes, resources. There we go. In the properties file. And when we've done this, JUnit will look for extensions that are part of the game, which are registered in the API extension file. And here we reach out to the org example extension slow class, which in turn was compiled in the beginning, just to have a look what's happening now. And here we have a extension which does wait half a second before and after each test execution. That means that once we run this command again, we see a slight delay on each test execution. Doesn't have to be asleep, could be some verification going on, some setup, some afterwards. What I wanted to show is when we have slow moving tests, we have also a details option which shows again which test is running. So before every test, we see a white line printing the entire path to the test, starting with the engine, container, up, down to the test. And after that, in this case, every test is successful. So we get a green line here showing that this test is good. So with that, I just want to see the difference between discover and execute, or the middle step is the dry run mode, which is basically execution mode without calling the test method. And for that, I have to go here and enable this command. So the JUnit platform execution dry run is enabled. And if I just run the tests now, it's very fast. None is really executed. All static containers were skipped. And we get a completely different output here that we are in dry run mode. So now listeners would have been called if there were any, and you could pinpoint errors you have while testing with the platform. Last thing for me to show is if you have the no color option on your CI system, because you don't want to see the ASCII escape errors in your logs, you can have this as no color. And if you run the console launcher again, you just get black and white. Or in this case, if I disable the dry run mode, no more green and yellow or red texts, just color. What you might have seen already is that the Suite engine is running a lot of tests, and if you compare it to the discover phase, there's a lot of tests going on. With scan class path, you can see here that there's a JUnit Jupiter inside the platform suite, and this is a topic that Juliet will now talk about.
Well, thank you, Christian, for the great introduction. You actually spoiled my whole demo with your logs. So, so now I'm going to speak a little bit about Suite, as you said, and about Jupyter Extension API later. So Suites. There was a highly requested feature over the years about Suites, which were the ability to execute code at the beginning of a suite and at the end. For example, if you're running integration tests and you want to set up some container or external dependency at the beginning of your tests that you want to reuse during your whole suite. So now it's possible via the annotation that were introduced in the Suite API. So before Suite and after Suite, which are pretty self-explanatory. And I'm going to show you how it works right now. So now you can see the suite that Christian executed just before with the ConsoleLauncher. So I'm going to execute it with my ID this time. And you can see that my suite contains everything in this package. And there are actually 2 test classes inside. And I put some logs for you to see what's in the suite. And now what I want to do is execute something at the beginning of the suite and at the end. So what I'm going to do is place myself inside the suite, the class, declaring the suite and adding some methods. So this method needs to be static, and they have to be annotated with before suite and after suite. And here I can put whatever code I want to execute. And if I run my suite again, you can see that the before suite method is executed at the beginning and the after suite at the end, and not the other way around. Would have been weird. Okay, so what I should mention is that you can have several before suite and after suite methods inside the class, but they won't be any. They will be executed in no particular order, so it's best to just keep one class of each type and execute stuff in the order you want. Okay, so that's it for the suite lifecycle methods. And now we will move on to the improvements that were made on the Jupiter side of JUnit with the extension API. So there was one new addition to the list of extensions that are provided by Jupiter since 5.9, and it is the TestInstancePreConstructCallback, which is a hard name to say. And basically, it does exactly what it says. It's invoked right before a test instance is being constructed. So if you want to write extension that executes at this point, you can use this. So it's an interface with one single method that is giving you some context about the test instance and also the extension context, which is provided to every extension. And this extension is acting as a mirror to the test instance pre-destroy callback, which was already here before. Okay, last but not least, another addition to Jupiter has been the ExecutableInvoker. So basically, this is an abstraction that allows extension to invoke methods which are taking parameters and provide some values that would be resolved by parameter resolvers registered in your test code. So, for example, if I have an extension resolving integers, and I have a method taking an integer as a parameter, I can say, please invoke this method using any parameter resolver you might find that are resolving integers. And I happen to have one, so it will provide the value for the parameter. So, like I said, any extension can access this via the extension context. So you can use this in any extension you might write. And this is actually already used by some built-in extension and third-party extensions. For example, we used this in the parameterized test extension to add some feature to the method source parameterized tests. So I'm going to show you this right now. Okay, so here I have a parameterized test using a method source, and I have a factory method providing the parameters for my tests. So here I have some users with names. And what I can do now is if I have a parameter resolver, so for example, here in my code, I have this, which is providing me some context object. And now, so this factory method used to take 0 parameter, and now I can actually inject this right into my factory method if I register my parameter resolver somewhere. And I can make use of it in here. So if I look at this, I can see that it provides me with a method giving me users. So for example, I can just retrieve all my users and create some arguments with it, like this. And if I didn't lie, it should execute my tests. So you can see that I have my the user from here that are used in the test. So this is an example just to show you how it works, but of course you can use this to inject for example Spring Beans or stuff like that to improve your tests. Okay, so now that we have factory methods taking that can take parameters, we could be in the case where I have 2 methods with the same name, and now I'm going to have to specify. So right now it's going to target this method, and I don't want this. So I will have to use the type of my parameter and put it here like that, so that the right factory method will be used in my test. Okay, so this was the method source example that is actually based on the executable invoker. And there is another use case for that in Spring tests. So it was actually used by Sam in the Spring extension to allow before transaction and after transaction annotated method to take parameters. So you might know these methods in Spring, and so now you can inject beans in these methods to be used inside them. So that's it for me. I'm gonna give the mic to Sam, who's gonna talk a bit more about parameterized tests and repeated tests.
Thanks, Juliet. Yeah, I'm going to cover some of the same things in a bit more detail with a different light. Yeah, my name's Sam. You might know me from Spring Test. I basically reinvented Spring's testing support back in Spring 2.5 and have maintained it basically ever since, the integration testing part. And I've been involved with the JUnit team for since the start JUnit 5. So let's dive in. One feature for repeated tests is this notion of failure threshold. So sometimes when you're dealing with a flaky test, you might want to abort the test after the first failure, or maybe after a certain specific number of failures, instead of just letting it run and fail and fail and fail, because that doesn't provide you any additional information. So starting with JUnit Jupiter 5.10, you can do this via the new failure threshold feature, and that looks something like this. So here we have at repeated test, the value, that's the number of iterations we want to run this test. And then we're setting the failure threshold here to 2. So it should fail at most 2 times. Here we're getting provided the repetition info as an argument to the method. And we're just simulating something that could fail like every second time or kind of randomly. So we're basically seeing if the current repetition is even or odd. When it's even, we're going to throw an exception. And then if we were to run that, there should be 8 attempts in general, right? If we didn't have the failure threshold there, it would fail for every alternating one. But with this threshold, what we see is that the output is actually like this. So here we do see the repetitions 1 of 8 through 8 of 8, but we see that the first one was green because 1 is an odd number. The second one failed, the third one passed, the fourth one failed, but then we reached our threshold at this point. So that's already 2 failures. And then we see the rest of the repetitions 5 through 8 are then skipped. So that can be handy if you're dealing with flaky tests. Next up, one of the changes we have in JUnit Jupiter 5.11 is that some of the source annotations that you can use with a parameterized test, things like @ValueSource, @MethodSource, etc., those things can now be repeated on the parameterized test method. And here we see one concrete example. So we have parameterized test, and now we have @MethodSource declared twice, once with category 1 files, once with category 2. And of course, as always, you can combine this with other types of argument sources as well if you want. But the thing to point out here is that you can now repeat these annotations, and the sources will then be basically concatenated. So you have this set of files from the first method and then from the second method. Next up, a new feature. It's called @FieldSource. This is basically a companion to MethodSource. So @MethodSource allows you to specify a factory method that will be invoked to provide the arguments. And with that field source, you basically point to a field to say where the arguments come from. Now that field could either be local in your test class, or maybe in a superclass, or inherited. And another option is it could be in an external class using the fully qualified method name. You might have noticed that Juliet used the fully qualified method name or a qualified method name to specify which particular method to use. And if you want to specify a field in another class, maybe like in a utility class of your own, in your production code, or maybe in a third-party utility, you can provide the fully qualified field name similar to the method name for method source. So that'd be like fully qualified class name, and then the hashtag, and then the name of the field. Another nice new feature we have that have been was also rather popular or asked for from the community is named argument sets. So before JUnit Jupiter 5.11, it was possible to provide a custom display name for individual arguments within a parameterized test, and you could do that via the named API, either named .named, the static factory method, or named.of. But you couldn't do it for the whole set. So now with JUnit Jupiter 5.11, we have a new notion of an argument set, and it's now possible to give a custom display name for an entire set of arguments, and that's possible via this new argument set factory method in the arguments interface. And that takes a string. So the first argument is going to be the name of the argument set, and then the rest of them, it's a var args object array. So those are actual arguments that you want to be passed to the parameterized test, and that's analogous to what you would have had before with the arguments method that just didn't have a name. So let's see those two combined. Here we have an example. So we've got a parameterized test with a custom display name. It's using @FieldSource, pointing to the field argument sets. Here we have argument sets. That's returns a list of arguments, and just using the list factory method here, list of, and now we're saying argument set. So this is a static import from the arguments class. So argument set important files, and then file 1, file 2, and another argument set some other files, file 3 and 4. And if we were to run that, that would look something like this. So we have the demo, the class, the parameterized test method container, and each of the invocations. So again, these are the names of the sets we provided, whereas the arguments would actually be these two files. So this the first file 1 and 2, and then file 2 and 3. Next up, arguments for method source factory methods. So again, this is something Juliet touched on before, but basically this is a way to, you could kind of say, parameterize your own parameterized tests, or rather take the source from somewhere dynamic. And previously that was only possible via custom arguments provider that you could hook in with the add argument source annotation. But now you can do this straight with a method source factory method, because they can accept arguments. As Juliet mentioned, that's made possible via the ExecutableInvoker. Internally, we use that. The arguments are provided from whichever parameters you have registered. And for an example, this could be something like a dependency injection framework, like Juice or the Spring extension, etc. And I'm going to show an example with Spring. So here we have an example palindrome test, just to show that works. It should be green. We have some results there. The candidates, 3 candidates are race car, radar, and able was aerosol elba. And we have a utility that just checks if those are palindromes and returns true, and this test passes. So what if we wanted to, what if we didn't want to use a value source for this source of palindromes? So if we were using Spring, maybe they came from a database or some kind of repository or some component in our Spring application. Let's see if we can code that on the fly. So let's call that Spring palindrome tests. So again, let's make it a Spring test, Spring JUnit config, and I happen to have a component here already. So this is a Spring service component, palindrome provider. It has a method get palindromes, and for the sake of the demo, it's just returning a static list. But let's say it might have pulled it from a database or some kind of file format or some REST client, etc. So that's the component we want to run with. So if we can, oops, if I could paste. All right, so it's going to load that Spring component, and it's going to run the test again. Let's just make sure that it's actually running. It's green, but right now it's still using this value source. So what if we wanted to use a method source instead? So let's take a method source, and we're going to have a list of strings, right? And we're going to say palindromes, and that's going to return, let's import Java to a list. So that's not returning anything yet. And we want to have this palindrome provider. So the way we can access that in Spring is we can say just add autowired from Spring and specify the name. There we've got that. And once you got that, we can say return, maybe go to the top, get palindromes, and we want to wire that up. So sorry, this doesn't go here, this goes here. And now we should be able to get rid of value source. So now we have the same test we had before, expecting the candidates, checking if it's a palindrome. But now the method source, in this case, it's going to use a convention, the same name, palindromes, is the test method. And this one here is the factory method. Oh, and that's going to need to be static by default. And now we're just saying we want to have this dynamically sourced from something in our application context in Spring. We want that palindrome provider bean to be injected in here. And then however it gets the stuff from the database, whatever, please just return that as a list of strings. We could also modify that, convert it to named arguments, argument sets, and stuff like that if we wanted. And if we run it, we hope that it passes, and it does. So we got palindrome tests. Sorry, this is the, oh, I guess I modified the original class. That's fine. So palindrome test is now Spring enabled, and it does run the palindromes with those 3 things sourced from the palindrome provider. So that's it from my end. Now I'll hand it off to Mark.
Yeah, thank you, Sam. So I'm going to continue on some more core extension improvements. So technically, parameterized test is also a core extension, but we have some smaller ones as well that I want to talk about today. And that is TempDir, AutoClose, and Timeout. So let's jump right into the demo. I'm going to start with TempDir. So TempDir has been around for a while. It's an annotation that you can put on fields in your test class. You could also put it on test method parameters. Both work. Just depends on what you prefer, basically. And what this does, if you want to test, it will provide you with a temporary directory on the file system. You can see it on here. I used a report entry here so we can see where it's actually writing the file to. And it also takes care of cleaning up the file and also the temporary directory. After the test is finished, it will delete everything as it should, just to not leave things behind and fill up your hard drive eventually, basically. This is all good and well, right? As long as everything's green, that's fine. But let's say the test fails. Let's just make it fail. I run it again. And you can see, of course, the content is different. I changed it to a question mark here, right? So that's what we're getting. Yeah, no surprise. But sometimes it's more complicated than just this one file with the content. And you would really like to look at the file or look at the directory and the other files in the directory. So as I said, it's cleaned up. So if I take this and I go to the terminal and I want to look at it, it's not going to be there, right? So that's not great. In case we want to debug things, this is less than useful. We could add a breakpoint, of course, here, but sometimes that's not even possible. If you want to run things on CI and it only fails there and you want to archive those files, then that's not an option. So one thing you can do is to use the new cleanup mode that we have introduced. So by default, it will clean up always. You can say it should never clean up anything. That means even if the test passes, it doesn't clean up anything. But what we usually propose is to use onSuccess in such cases. And that means if the test is green, it will clean up the temporary directory. But if it fails, it will leave the files behind so you can inspect them. So let's try this. And yes, you can see here, we want to test. You can also get this info message that it actually wrote the TempDir. So you always get that even if you don't have this custom report entry published. And it says that it's due to the cleanup mode configuration that we have done up here. So now if we take this, we should be able to navigate to that directory and look at the files. In this case, it's just one file, right? But we can take a look at that, and it's, as expected, the file that we have written in the test. But of course, this could be way more complicated. If you call some external command that produces files, then you really want to take a look at that. And this is what this is for. All right, this is the first TempDir feature, but there's another one that I want to show. As I said, if you run this normally, let's make the insertion pass again. So that was the wrong shortcut. Now you can read it. Okay, now the test passes again, and you can see this is on the local file system. I'm using Linux here, so it's a Linux file system, and it's, yeah, I could navigate to it using the terminal, right? So it actually is in my file system. But you could change that. For example, one use case is you want to use a temporary in-memory file system. So like, for example, GMFS is one such implementation. And I have written this locally here. This does not come with JUnit. It doesn't have a dependency on GMFS. But you could easily implement this TempDir factory. It has two methods: create temp directory, which is responsible for creating one, and close is responsible for cleaning up things. So in our case, we are creating a new file system in the constructor. We're then using that file system here in the create TempDir directory method. And finally, we are closing it in the close method when we're done with this particular temp directory. So let's go back to the class. And now if we run this, yeah, it looks the same, right? The test here doesn't care which file system this path is in. But you can see here from the report entry that it's actually using the GMFS file system and, yeah, doing that, right? You could also just implement this, for example, if you want to have some custom initialization of your temp directory, maybe create some files in it or in the regular file system. Doesn't have to be a different file system. This was just for the purpose of the demo. All right. That concludes the TempDir part. The next thing I'm going to show is the AutoClose extension. And AutoClose is relatively new. It's an annotation, again, that you can put on fields of your test class. In this example, I have 2 of them. The first one uses an HTTP client, the one from the JDK. And the second one uses just some local little class here that is actually just a little wrapper around the HTTP server that comes with the JDK as well. So it's a little more convenient to use. And what it does is it manages this resource for you. So you declare it here as a field, but if you remember, HTTP client has a close method, and that needs to be called in order to shut down thread pools and whatnot. And instead of writing this in an after each method, the AutoClose annotation allows you to kind of write your test more concisely, but just specifying the annotation, and it does the cleanup. In this case, we have passed the method name actually that is used here for the local HTTP server. There's a stop method in it that we call, and this one is called via reflection from JUnit, which is something the IDE doesn't yet know, so it will warn you actually that there's a potential unused method if you don't annotate this with suppressed warnings. So we can run this test. It's gonna work, right? So it uses just this HTTP client to send a request to the server and gets it back again and with the expected response code. This is just for the sake of a demo and to demonstrate that AutoClose makes it more convenient to work with closable resources, and provides a way to declaratively specify that they should be closed at the end of the test. All right, my last demo is about Timeout. So let's see that in action. Timeout is a way to declaratively specify that each test method, so you can put it on the class level, but it will basically apply itself to each test method, should finish within a certain amount of time. And by default, it's in seconds. So this is 1 second. You could specify the unit. And that's not new. But what is new is something that I'm going to show. I just need to motivate it a bit more first. So if you run this test in a normal configuration, what you will see are two tests here. The fast one is pretty fast, 60 milliseconds. The slow one is 500 milliseconds. You can already see the main thread is used. That's why it's current to run the test. And there's another thread that JUnit creates to watch that it's actually finishing in time. And if it doesn't, it will interrupt it. So let's make it more slow by adding, by making the timeout 5 seconds. Now, if you run this again, you will see that the test fails after about 1 second, which is the timeout that we have configured. And it will be interrupted on the main thread. And you will get this test failure that slow timed out after 1 second. All good, right? But in this case, the code under test, which is just here in this test method for this example, actually behaves nicely as it should. It actually responds to interrupts. So in this case, we catch it, we lock this, and then we finish. But what if that wasn't the case? So let's call this wait indefinitely method here. Implementation is not important. It will just wait and not continue. So let's run that. And you will notice it doesn't finish, right? So I could this run indefinitely. It wouldn't finish because the code doesn't react. It hasn't responded properly to this interrupt, basically. And yeah, I'll stop it after 15 seconds. So that's not something that would happen. It would run until I basically stop it, and there's nothing to do. So that's not great, right? In some cases, you don't really maybe control the code under test to that degree that you can change things and make sure it properly responds to interrupts. So what can you do? We introduced a new thread node parameter. So you can say, I want a separate thread to run my tests. So now if I did this, you will see that it now finished after 1 second. It failed because it ran into the timeout, as it should, because we sleep for 5 seconds here. But you can also see that the behavior in the thread is different. So the main thread is no longer used to execute the test method, but rather there's a timeout thread here, timeout thread 2. That's the current thread when this test method is being called. And you can see the test finished it didn't hang, all is good, almost. Because the thread that we started here, thread 2, well, it didn't respond to the interrupt. So in Java, there's nothing else you can do really. So what happens is that this thread will actually continue running even after the whole test class is finished, which is what we're logging here after all. So it does have the potential to leak threads. And there's only a limited number of them. So you should use this sparingly, of course. And yeah, but it's an escape hatch if you have something like this and want to configure things differently. All right. You can also configure this, by the way. Just wanted to mention this very briefly. Globally, that's the wrong file. Here, so you can actually specify a default timeout that applies to like all test and lifecycle methods in seconds or minutes or whatever you need. If you don't want to apply this timeout annotation all over the place. And if you need to, we can also configure the default thread node that I just showed here as a configuration parameter as well. All right, this concludes my demo. Now, I want to say a few words as an outlook, and I also want to start with some good news. And the good news is that the Sovereign Tech Fund is investing in JUnit in 2024 and 25. So most of you probably don't know what the Sovereign Tech Fund is. It's a German government program to strengthen the open source ecosystem. It invests in foundational technologies that enable the creation of other software. And we're really super happy that JUnit is considered one of those. If you want to learn more about this, there's the website here as a link of the Sovereign Tech Fund. The bottom line is what this means for the JUnit team is that I will get to work full-time at JUnit for about a year. And I started in September, and I'm still super excited about this. And yeah, I think a lot of good will come from this. And one of them being the next release, so JUnit 5.12. This will actually go out sooner than we normally would have had another release. JUnit 5.11 was, just in August, September-ish. So this will be in February next year, probably. That's the current plan. And the main highlight for me is open test reporting, which is something that we have already done previously as an XML format. But now this project is capable of generating a very useful HTML report for your tests that supports all of the features that JUnit has, like nested tests and hierarchies and report entries and so forth. And we'll even be adding the capability to JUnit and open test reporting to attach files, such as screenshots, for example, if you do browser testing, to test results. And on the right, you can see like some screenshots of what it looks like, but it's still in development. And yeah, we are really looking forward to seeing this in action, especially like on CI. If you can archive this and look at your test results, this will be very useful, we think. The other highlight is improved support for resource-based test engines, such as Cucumber, and it will bring it up to speed on par with what we have for class-based test engines like JUnit Jupiter, as far as test discovery goes, and finding resources in directories and packages and so on. So this means that there'll probably be another release next year, which I can also already spoiler a bit, because we already have things planned out. And the main highlight for me here is parameterized test classes that I've been wanting to do for such a long time. And sometimes you have parameterized test methods in the same class that all take the same parameters. And you would really like to avoid all that boilerplate and specify it once that each test basically is using the same parameters. And this is where parameterized test classes will come in and hopefully be very useful. Another long-awaited feature is a test discovery validation mechanism that we plan to introduce. The idea here is that to surface user errors that otherwise would go unnoticed. For example, right now, if you declare a test method and just specify a return type, you can return null, whatever, it doesn't matter. It will not be found. And JUnit will silently ignore this method. But probably your intention of putting the test annotation on that method was that this should be a test, right? And so especially if people are not just starting out with Java or JUnit, they might not be super familiar with that. So we really want to surface such errors better and provide a mechanism to do so also for other test engines. We want to improve the usability of documentation, make it clear that you maybe not the latest version of the documentation and give you a version picker so you can actually look at the right version of the documentation. We want to improve the Kotlin support. Things are already kind of, in progress as far as contracts go, but we plan to add sequence support and other things that will come out as a nice package for our Kotlin users. And last but not least, safe cancellation of test execution. Currently, if you run tests and you want to kind of stop after, I don't know, let's say 10 failures, the only way this is doable for build tools and IDEs is to kill the Java JVM that is running the tests. And that means that things are not shut down properly, test reports might not be written correctly or closed correctly and all of that. So this is a way of gracefully shutting down and saying, I'm not interested in any more test results, please stop. And that's currently the plan for the next release. There are a few links here for you. The code examples that we've shown today are on GitHub in this repository in the JUnit team org. And anything else, if you want to read the user guide, the Java doc, or have a question that we don't get to, maybe not in a second in the Q&A, you can just go to junit.org and you'll find all the links there. And you can also report issues, of course, and everything, right? That's your main starting point, and it should be easy enough to remember. Yes, and with that, I kind of invite the team back, and we have time for a few questions, I think.
So first of all, everyone, thank you so much. It was an amazing session. I'm still impressed by the time that you took to cover so many things, because it's difficult for even one person to stay on track with respect to the time, and managing that with 4 of you. Oh, that was amazing. Of course, the content, that was amazing, a mix of demo and the slides. That was great. Thank you so much. And everyone watching the session, please share your feedback using either the QR code that you can see on your screen right now, or using the link. It takes just a minute or two to share your feedback. That really helps us to plan our next live streams. And on that note, I would bring the first question. Where are my start comments? So I asked which version of JUnit everyone was using, and we had a couple of answers. So one was about just using JUnit 5, and Carl is here. So hey, Carl. So he said he's using JUnit 5.11. And the other one was, so this was concerning, like whatever Spring Boot recommends. So do you have any comments there? Because a lot of time developers use the version which is offered by, suggested by the framework. So do you have any comments there?
Well, if you're using Spring Boot, one of the main reasons is for the dependency management, knowing that things have been tested together and they work. So I'm a bit biased because I'm on the Spring team, and I think that's actually a nice way to go. And people can always upgrade it. The thing is, if they're on a recent version of Spring Boot, the Spring Boot team is automatically upgrading to the latest released version of JUnit anyway. So that's actually been really beneficial to us in JUnit, because once it started being the default instead of JUnit 4, in Spring Boot, all the Spring Boot users in the world started using the latest versions of JUnit Jupiter, and so we benefit from that. So personally, I like it. But
sounds good. So I am not sure when did we get this question. So the question is about the advantage of using a standalone runner over using Gradle. Christian, it was either your content or Juliet's content. So I'm sorry,
I guess
I missed
so.
that part.
And if you replace Gradle with any build tool, the advantage is if you don't have a build tool or want to deep dive into a problem that a build tool poses to you, there is an option. So it was the first client, the first user of the platform, and it will be the last when all build tools are gone. So this is for you to deep dive, to play on plain metal, and it's an option.
Makes sense. So Juliet, this was for your content. Why no extension support on these before and after the suite methods?
I'm not sure I understand what does this person mean by extension support.
I think the answer is that they're probably thinking about extensions like we have in Jupiter, and the before suite and after suite are not tied to Jupiter at all. They're tied to the platform and particularly to the suite engine. So there is no extension model at the suite level. I hope that answers the question.
Tony, if you have any follow-up questions, you can have them ask the questions now so that we can ask any if that doesn't already answer your question. So there was an interesting question. So even though Carl and Christian already answered some points, if you want to add anything to it. So this person wants to know about you to talk about JUnit support integration with the Java platform module system.
Yeah, sure. First off, JUnit doesn't impose any kind of framework, assertion library, class path, module path, whatever. And we never had an issue with breaking changes within the JDK. So if you are using the module system or not, and your build tool supports it or not, does not depend on JUnit. And our code to reflect where the test code is and how to execute it. So if your build tool did work before, it should work after. Now, with the new boundaries of the module system, there can be some challenges within the build tools. And of course, you can dive deep into that. You have to either live with the module boundaries or you have to peek into some packages. But that is nothing that JUnit can help with. That is something that your build tool needs to answer and to support you. So nothing changed since 2018 or even before. And maybe that's a good option to have another stream about this very topic in the future.
Yeah, one thing maybe to add that is like JUnit is of course shipping with module descriptors, so it's the all kind of Java proper modules. So we really try to do what we can to make it possible to test the module system or with OSGI for that matter, right? We also ship with OSGI headers included. So we really try to play nice with everything the community uses. And if you have like a more specific question, we can maybe help. But it's kind of one of those questions that it's like at the boundary of JUnit and the build tool, because it kind of depends how you compile your code, how you then run your tests, and it's often triggered by the build tool.
Yes, this is exactly what Carl also mentioned about the module descriptors. So I guess, yes, that was kind.
I didn't see that. Okay, cool.
So there's another question by Giovanni, and he's saying, I'm dealing with JUnit test, which depends on config files to be executed. How can I have JUnit to peek those files? I tried with Surefire plugin settings, but no way. So Carl responded, and okay, no. So this is more of a question, a follow-up question. So I'll just show this again to you. Yeah, sorry.
I'm also not quite sure what's being asked there, what kind of config files and what they mean by peek.
Okay, so that's okay. Giovanni, if you're already on the call, let us know if you have any more details to add to your question.
I would just take this opportunity, Marla, sorry to interrupt. We have like a GitHub discussions section on the repo, right? And there's also Stack Overflow with the JUnit 5 tag. So if any question is there tonight that we can't answer because of time, or we can't answer properly because it's too technical to discuss without looking at code, then please use that as a kind of vehicle to ask a question.
That makes sense. And I'm sure a lot of people would already have asked this question to you, how to get involved in JUnit work. So how they could contribute. So
yeah, so like last Saturday, we actually attended a kind of hacker garden event in Switzerland. So that's one way. We might do this in the future again. There were a couple of people there that were interested as well, right? Like if you do want to do this now remotely, then we have like an up for grabs label. I think right now, though, all issues labeled with up for grabs are already in progress. So it's quite a popular project to contribute to, which is cool, of course, right? But yeah, that's one way. Look at that label, see what's up there. Of course, the issue tracker is on GitHub. So if there's anything that you think is something you're really curious about and maybe isn't too complicated, then you can always ask. You can always post a comment there and ask the team if you could work on this, and we can discuss, right? If that's already in a state that you can pick it up, or maybe need some discussion first, that's what I would answer to that.
JUnit is for sure a very popular project and everyone wants to kind of contribute to it. So there's even a suggestion from Stefan, and he's suggesting if you would like to have a talk at Boston and the CFP is still open. I'm wondering if he is already on the selection committee or he could extend an invite. No, just kidding.
Yeah, Stefan was actually on the JUnit 14,
yeah.
so it's nice to see him again. I'll ping him afterwards.
Okay. I think Christian already answered that question. So this was a question from Tony regarding reports. How are you going to compete with Alludo? And to which Christian has already answered. Sorry, I missed that part. That why compete? It's more like offering a built-in option. So if you want to add anything to it.
Like I wrote, it's not a competition here. It's just the data is already there in XML format. You can transfer it between a streamed and a node or a hierarchical format, and now we have also an HTML format of the same data. So it's not invented as a competition, but as an option to better view directly out of the box what's going on.
Yeah, I would also add to that. It's for us, it's a great way to make sure all the features kind of work end to end to actually see things in that report. And yeah, I mean, if people want to use Allure, that's totally fine, of course, right? It's just the one kind of official option that we provide.
So Oliver mentions, I wonder if the standalone runner would be a nice way to test JBank scripts.
And I think it already is supported or documented on the JBank website that you can run JUnit tests with some comments starting your source file, and then everything will be green every time.
You can use JUnit via JBank, the ConsoleLauncher, that's true. I'm not sure that's what a JBank script is like. Yeah, the thing, I don't know how do you test those, to be honest. So
let's find out. Let's start a discussion. Oliver, you just volunteered to find out and tell us.
Yeah.
So there's another one by Ruben, and he say, I use the managed dependency version because it usually requires less time to fiddle and manage versions. For most of the cases, we don't have to maintain version or have an exotic mix of version. I'm not sure, do we have a question there or just a comment?
Maybe that like a follow-up to
the Spring Boot managed dependency. That's what it sounds like to me. Yeah.
Right.
Yeah.
So this is a question. Is there any plans, if not already, to collab with Open Rewrite from Modern to reduce the friction for trivial migrations, changes of 5.x to 6.x? I'm thinking about JUnit rules from 4.x to 5.x.
Those recipes exist at Open Rewrite already. So there's a bunch of going from 4 to 5. You can already leverage, and there's also one going from JUnit to TestNG, and I'm working at the moment from going from TestNG to JUnit. So it's all across the board, vice versa. So happy to help, happy to commit and see that everybody's using the framework wants to use.
And we don't have a JUnit 6 yet, right? So there's no changes from 5x to 6x. So that remains to be seen. But one thing that could you imagine is that things might not change that much for the programming model and the extension model. If we've done a good job, we won't break people's code in that regard. We'll just add new features and new enhancements. Fingers crossed.
So Marit is suggesting a summit for Workspace Amsterdam, and she's on the committee, selection committee. I know that for sure. Okay.
Is she inviting all 4 of us?
I
Sounds
guess,
like.
Yeah.
Thank you, Marit.
Okay,
invite me to propose, right? Not to come over for beer.
Okay, so so we have comments now. There was a question, but we don't see that question. So Sergey, we don't see your question. I guess it's missing. So you, as Mark said, you could have that on the discussion tab on the. Sorry, Mark, if you could repeat that. I'm so sorry, I missed that.
Leave out the link. Now the questions there with the current plan for issue GitHub.
Yes.
That was very specific.
Yes.
That's for Sam.
Yeah,
Sam, you
that's one for
know.
you, Sam.
Let's see. Oh, what's the current plan for issue GitHub? Springs. Oh, an issue number. Uh-huh. You order test members.
Just scan the brain.
Um, I believe that is in the general backlog. Some other things have fallen onto my plate in recent months. Hopefully, I'll be able to look into that over the next few months, potentially for inclusion in 7.0 towards the end of next year, but I can't make any promises at this point.
Thank you so much, Sam. So great presentation. And there was another thank you message. And there was another thank you message. Christian, thanks for answering the question. And Sergey says, thank you so much. So thank you so much, everyone. Again, great session, great Q&A session. And as I said, the presentations by all of you were absolutely great. And everyone watching, please use the links, the social links on your screen right now to follow the members that presented today, and also the ones that we have for IntelliJ IDEA. And we have the next session on 12th of December by Siva. He'll be talking about the restructured project window for your enterprise applications. And before we say bye, everyone, if you have any closing remarks, yes, and do not miss to subscribe to our channel. Yay! Okay, and before we say bye, everyone, if you have any closing remarks, please.
None, obviously.
Thanks for joining.
Keep on hacking, keep on testing.
Yeah,
everything should be green.
Test your
Keep
good.
the bar
Test
green,
your
yes.
good. Yes. Thanks, everyone. Bye-bye.
Bye.
Bye.
Thank you. Bye.
Cheers.
Bye.